Hi everyone, today we are going to tackle significant figures and we're going to specifically go after those oft misunderstood but very important zeros and knowing when they are significant, when they are not significant. So today is just identifying how many significant figures are in a number, and we're not going to mess with any kind of operations. That's going to be for other videos. The first thing we need to take care of is the easy one. These are non-zero integers. Any non-zero integer is going to be significant. So my first example here, 125, all non-zeros, that has 3 sig figs. My second example here does have a 0 here. However, that is just to make it easier for the reader to see where that decimal place is. It is not actually necessary to write the number this way. So this one actually just has 5 sig figs, and they are all non-zeros. And my last example here, this is another 3 sig figs, again, all non-zeros. All right, that's not a problem. That was just some quick review. Let's go on and let's jump into these zeros here. All right, so we've got 3 rules that we're going to apply. Let's start with our easiest. Let's start with our captive zeros. All right, so your captive zeros are going to be zeros that are between 2 non-zero digits. So if you look at my first example, 506, this 0 is in between 2 non-zero digits. It's in between a 5 and a 6. Therefore, it is significant. So that number has 3 sig figs. All right, now a captive 0 doesn't have to be 1 0 by itself. If you check out my second example here, I have 2 zeros, but they are still between 2 non-zero digits, so they are, yes, also significant. So my second example here has 5 sig figs. Both of those zeros are significant. All right, let's check out my third example for captive zeros. You see I have 2 different sets of captive zeros. I have a single captive 0 there and 2 captive zeros there. But again, they're all still captive zeros even though they're in different places in the number. So they are all significant. So my third example here has 6 sig figs. All right, so captive zeros, yes, significant. All right, rule number 1 down. Let's head on to rule number 2. Let's switch up color just to make it a little more interesting. Okay, so rule number 2, leading zeros. All right, so leading zeros are zeros that lead into your number. So if you look at my first example here, I have, again, I'm just going to call this 1 leading 0. This one just shows where the decimal place is. So I have a 0 before my first non-zero digit. That is not a significant 0. So you don't count. I only have 3 sig figs here. All right, let's take a look at my second example here. Again, here I'm going to circle my leading zeros. They are before my first non-zero digit. They are not significant. Ooh, but however, tricky. I have a captive 0 here. Now we've already gone over captive zeros. We know they are significant. So this is an example of a number where some zeros are significant and some zeros are not significant. Captive 0, yes, you get the green light. I have 4 sig figs. Okay, let's take a look at my last example here. This one looks like it should have a lot of sig figs. We've got a lot of digits here, but if you take a look at it closer, all of these zeros are leading zeros. You are not significant. This number actually only has 1 sig fig. Okay, let's switch up colors again. Let's go for a nice bright green. Okay, now for the one that everybody hates, trailing zeros. Sometimes these are significant and sometimes they are not significant. We need to know there are 2 rules to make trailing zeros significant. The first rule being that the 0 has to be to the right of a non-zero digit. The second rule being it has to be to the right of the decimal point. If both of those conditions are fulfilled, then that trailing 0 is significant. However, if just one of them is fulfilled, it is not significant. All right, let's dive into my examples here. So my first example, 1,000. I have 3 trailing zeros. Yes, they are to the right of a non-zero digit. Okay, that's good. But are they also to the right of a decimal? No. Sorry, zeros, you don't count. This number only has 1 sig fig. Okay, let's go on to my second example. I've got my trailing zeros here. Yes, they are to the right of a non-zero digit. However, they are not to the right of a decimal. You do not count. But what about this guy here? Yay, this is one of my easy ones. That's a captive 0. Yes, that one is significant. My second example has 3 sig figs. All right, let's keep going because these can kind of be tricky. Here are my trailing zeros. Yes, they are to the right of a non-zero digit. Oh, and check it out. They are also to the right of the decimal point. They fulfill both conditions. Yay, you guys are significant. Okay, what about these zeros here? Those are leading zeros. They are not significant. They do not count. So for my third example here, I have 4 sig figs. These zeros are significant. These zeros are not. All right, now for a nice long one here. Okay, I got lots and lots of zeros here. Let's tease these out and figure out which ones are significant and which ones are not significant. Okay, so here I have leading zeros. We've already determined leading zeros, no good, not significant. Okay, if I come to the middle of the number here, I have 3 captive zeros. Yes, those are significant. You guys are good. And now I have 3 trailing zeros. I need to double check my 2 rules. Okay, so are they to the right of a non-zero digit? Yes. Are they to the right of the decimal? Yes. These are significant zeros. So I have 6, 7, 8, 9. I have 9 sig figs in this digit here. Okay, and my last example, I threw this in. This is a little trick here that sometimes scientists will use to make trailing zeros significant even when they look like they shouldn't be. So if I take a look at these 2 zeros, they are trailing zeros. They are to the right of that non-zero digit, that 3, but they are not to the right of the decimal. However, let's say I'm writing a lab report and I need to tell the reader that these zeros actually are significant, to say, hey, look, I know when you're looking at this number, they look like they're not, but I need to tell you that they are. Well, one kind of quick and dirty trick is to put the decimal point there, and then that makes those zeros significant. So this number actually has 3 sig figs. So putting that decimal point there is a little trick you can use if you need to make those trailing zeros significant, but they are not to the right of the decimal. Hopefully that is clear as mud now. We have a couple more things to talk about. Let's go talk about exact numbers now. So I'm going to go back to my blue color. Exact numbers. So these are very often conversion factors, as you can see right here. If you're talking about how many meters in a kilometer, how many milliliters in a liter, nanometers here, these are all exact conversion factors. They are definitions. So by definition, a kilometer is defined as exactly 1,000 meters. It's not 1,000.1. It's not even 1,000.001. It is exactly 1,000 meters. So if you have an exact number, that means you have an infinite number of sig figs. Okay, so that is true for all these conversion factors. Now I want to take a look at my last example here. This is kind of an interesting case of a conversion factor. So this is a conversion factor. It looks like it is not an exact number because this does not look like it's a definition like my 1,000 meters and 1 kilometer up here. But actually this is an exact conversion. Now, oftentimes what you will see is written in parentheses afterwards. It'll say exact. So like the writer is trying to help you out here. This is an exact conversion. So yes, it does have an infinite number of sig figs. Okay, and the other kind of exact number you can have is a counting number. So if you were doing an experiment and you used 10 people, that is an exact number. You can't use 10.1 people, or you can't use 9.95 people. It's 10 people exactly. You can't have fractions of people. So that is an exact number. That number actually has an infinite number of sig figs. The same is true here if you're counting up atoms. So for example, I'm counting up atoms of carbon. Okay, yes, we can talk about fission and all of that, but for the purposes of sig figs, when you're counting up, say, again, numbers of atoms, you're not going to have 5.6 atoms of carbon. You're going to have 5 atoms of carbon, or maybe you have 6 atoms of carbon. That's an exact number. Therefore, it has an infinite number of sig figs. Okay, clear on exact numbers? One more thing to talk about. Let's talk about scientific notation, and I will show you why I love scientific notation so much. Scientific notation, let's take a look at my first example here. I put in a really easy one. You can see this is all non-zero digits, all right? So this has 4 sig figs. Notice I don't include this part of the scientific notation in determining my sig figs. My second part of my scientific notation here only tells me where to move the decimal place, so it's not part of counting up your sig figs. So only this first part. So I have 4 sig figs here. Okay, let's take a look at my second number here. All right, so I've got those pesky zeros. These are trailing zeros. Again, these are tough because we have to fulfill both of our conditions. Okay, so are they to the right of a non-zero digit? Yes, yay. Are they to the right of a decimal? Yes, yay. They are significant. So I have 5 sig figs here. Now, notice when I'm using scientific notation, this digit, again, if you're remembering your format for scientific notation, that digit will always be a non-zero digit. You'll never have a 0 there because then it's not in scientific notation correctly. So any 0 you have over here is automatically going to be to the right of a non-zero digit and to the right of a decimal place. So they are going to be significant automatically. Okay, so let's take a look at a little more difficult example here. What we've got is we've got some zeros here and some zeros here. Okay, so let's do our easy ones first. These are a captive zero. Yes, captive zeros are significant, no problem. Okay, again, we got trailing zeros, so let's make sure both of my conditions are fulfilled. Yes, it is to the right of a non-zero digit. Yes, it is to the right of a decimal point. Yes, they are significant. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 sig figs in this number here. Okay, just to highlight again the awesomeness of scientific notation, I've got just a number here, but I've written it in standard notation and I've written it in scientific notation. Now again, if you're writing a lab report or maybe you're writing a paper to submit to a scientific journal, right, we can always hope, and you need to tell the reader how many of these trailing zeros are significant, you're going to have a really difficult time doing that in standard notation. Because how do you tell the reader, oh, I want you to cut off right here? Well, the way you tell the reader to do that is you don't use standard notation, you use scientific notation. Because again, you can add as many zeros here as you need and they're automatically significant because they are to the right of a non-zero digit and they're automatically to the right of the decimal point. These are going to be significant. Again, if I'm seeing a number up here in standard notation, I'm going to automatically assume all of these zeros are not significant. Now you can say, wait, you showed me that trick, we use the decimal place. Okay, well, if we put the decimal place in here, that makes all of the zeros significant, but I don't want all of them to be significant. I just want 3 to be significant here. Again, this is why I love scientific notation because it's flexible and it lets you put in however many sig figs that you need in a number. Okay, so we have these trailing zeros. They are significant. We've got a captive 0 here. Yes, that one is also significant. So I've got 1, 2, 3, 4, 5, 6, 7 sig figs here. But if I came up to this one and I counted up sig figs using my rules, I just have this one captive 0 that's significant. This one only has 4 sig figs. So I hope this helped clarify sig figs. I know those zeros are so confusing and they tend to give students fits and they get very frustrated over it. But really, as long as you follow the rules, you can determine how many sig figs you have. Thanks so much for watching this video. I'm also going to link videos on how to use sig figs when you're doing addition, subtraction exercises, multiplication, division exercises, and of course, when you're mixing and matching all of those, and how do you keep your sig figs through those really long and difficult calculations. And of course, don't forget to subscribe. Thank you.